Okay, so in this second video of my Rationality playlist, I'm going to give sort of a brief walkthrough of propositional logic. And so a proposition is essentially a statement that is, you know, that is X is P. And so we are sort of predicating P of X, and X is sort of falling under the concept of P. And so we would say, like maybe Putin is Russian. Uh, Russian. That's just the first name that came to my mind since it's in the news. But so we see that Russian is this concept under which Putin falls, but Russian is sort of a property that Putin has. And so that's, sort of in a nutshell what a proposition is. But then we can sort of combine propositions using things like conjunctions and disjunctions and things like that. And so up here I have, these are some what are called truth tables. So the first one I have here for the conjunction, which is the and statement. So we see that we have a proposition P and a proposition Q. And if both P and Q are true, then so is the conjunction of them, the proposition P and Q. So kind of the combining of those two propositions. And then anything else is false. So if P is true but Q is false, or the other way around, then the conjunction of them will be false. And then obviously if both of them are false, then the whole thing is false. And so we might say that a conjunction of this would be, so we might have like water is below freezing, so I'll just put an F there, and is solid. So these are two propositions, and if we do the and of them, then I say H2O. So H2O is, and we'll say BF for below freezing. Then we can also conclude that H2O is solid. And so if we know that P and Q, H2O is below freezing and H2O is solid, then somebody says this H2O is below freezing, then we know that this H2O is solid. And so that's kind of how that connection works. So then the next one we want to look at is the not, operator here. And so that's just saying that if we have some proposition P that's true, then the proposition that P is not P is false. And then same, if the proposition P is false, then the proposition not P is true. And so, we might go over to our Putin is Russian here. So Putin is Russian. If that is true, then Putin is not Russian is false. And so you can see that. And so I put this little symbol here, so you'll a lot of times see not as a symbol that looks kind of like that. You'll also see the sort of tilde symbol that looks like that. So those are both things you will encounter as the not symbol. And then of course over here, this little sort of partial triangle pointing up is the and symbol. And then the partial triangle pointing down is the or symbol. So here we have this disjunction, and this is or. And you could almost think of it as being like P or Q and, P and Q, or I guess more likely P or Q or P and Q, because it's called an inclusive disjunction because it's also true if both of them are true. So if P and Q are both true, then P or Q is true. So if you have the exclusive or, which I put down here, then you see that the difference is that if both of them are true, then the P or Q is false. You don't run into the exclusive or that often in logic, but I wanted to put it up here just to sort of point out, just sort of drive home the point that this disjunction, this inclusive or, is, as I said, inclusive. It includes the P and Q statement. And so we could maybe say, as a concrete example, we might have sky is cloudy and sky is sunny. And so we say that the sky is cloudy or the sky is sunny. But you could also, I guess, say, well, if it's partially cloudy, then the sky is cloudy and the sky is sunny. And so that would be sort of the inclusion. But we see here, if we have P or Q, then we say not P, then we know that Q. So for instance, we say the sky is cloudy or the sky is sunny. The sky is not cloudy, therefore the sky is sunny. This doesn't work if you just sort of accept the P here, because then Q could be either Q or not Q. So you could maybe even say we could have P or Q, and then we have P, then we would have to say P or not P. So we would have to have that because you can't say one way or the other if all we are doing is affirming this P here. So if we are negating the P there, then we can say for sure that Q is true. So if we say that if we're negating the sky is cloudy, then we know for sure that the sky is sunny. All right, so over here we have the hypotheticals, and I touched on this a little bit in the previous video. And so when we are talking about hypotheticals, what we have, so just a little terminology, they are if-then statements. So we have if, and then the statement here is the antecedent statement, and then we have then, and that is the consequent statement. So we have antecedent and consequent. So if antecedent, then consequent. And you'll see that written like this. You'll also sometimes see it written with sort of this sideways U looking thing like that. So sometimes you'll see it like that. Sometimes you'll see it with the arrow. And so modus ponens, which is you could probably call affirming the antecedent. So affirm antecedent. So I'll just put affirm ante. And so that's saying that if P, then Q. P is true, therefore Q is true. And so you might think of something like if rain, then wet. Rain, therefore wet. So if it's raining, then it's wet. Well, it's raining, so that must mean it's wet outside. And so that one is usually pretty easy for people to grasp. I mean, that's, kind of the quintessential if-then statement. If X, or I guess if P, then Q. P, therefore it must be Q. But modus tollens is one that I think can trip people up a little bit. And so this is negate or deny. So we'll say negate or deny the consequent. And I'll just put cons like that. And so that's saying, if P, then Q, not Q, therefore not P. And so if we use our rain example, so if rain, then wet, not wet, therefore not raining. So you look outside, you see it's not wet, you know that it's not raining. But what we can't do is sort of negate or deny the antecedent. So if we say, if rain, then wet, then we say not rain, we are not able to say not wet, because there could be some other reason that it is wet outside. There could be a sprinkler or a broken water main or something like that that would make it so that it is wet, even if it's not raining. And so the only way for this to work is if we are affirming the antecedent, which is modus ponens, or if we are negating or denying the consequent, which is modus tollens. And I think this right here is probably a place where a lot of people get tripped up, that they essentially think that, if P then Q sort of entails if Q then P, but that is not the case. So I guess we could say that if we sort of affirm the consequent, that does not then affirm the antecedent. So we cannot deny the antecedent to deny the consequent, and we can't affirm the consequent in order to affirm the antecedent. It only works if you affirm the antecedent to affirm the consequent, or negate or deny the consequent in order to negate or deny the antecedent. And so those are how hypotheticals work. And so what we're going to be looking at here now is what are called categorical syllogisms. And so these are sort of the quintessential sort of Aristotelian kind of syllogisms. And so these are the ones where we have every or all S is P, or we can have no S is P. So we see these Venn diagrams here. So if all S is P, then there's this none here, because none of it will fall outside of the P. Only here, where it falls inside the P, will you find any S. Then over here, sort of the opposite. Where these things overlap, you will not find any S within P. Then down here we have some S is P. And so we're saying that, some of the S does in fact lie outside of P, but some of it lies inside. And just to be clear, in logic, using some can mean, pretty much anything between sort of not including zero, so not including zero all the way up to all. So even just one thing, even if just one S is P, then we would say that some S is P. Or if we say that, 99% of S is P, we would still say some S is P. In usual everyday parlance, when you say some, you kind of mean like not one, but not, most of them. If you wanted to say most, you would say most, but in logic, some kind of covers everything from one to most to, almost all. So anything not including zero and not including all, so anything in between there. And so we also then have some S is not P, which you can see, so we're talking about this right here, but some S is not P does not tell us that that there is no S that is P. In fact, if we go over here, so this is the sort of the table of logic that is popular in sort of introductory logic classes, and so it's looking at sort of how all these things are sort of related to each other. So we have all S are P is contrary to no S is P. So contrary being that they cannot both be true at the same time. Then, of course, this subaltern, which the all and some is subaltern, and then the no S and some S are not are subaltern. And that just means that the particular is implied by the universal. So if all S are P, then it follows that it's true that some S are P. If say all humans are mammals, then it follows that that some humans aren't mammals, because any subset of humans that you look at is going to be mammals. And same with the no. So if no humans are birds, then it follows that some humans are not birds, because if you look at any subset of humans, they will not be birds. And then so contradictory cannot both be true or both be false. And so if some S are P, then it cannot be true that no S is P. And if no S is P, it cannot be true that some S are P. And so these two things in the corner from each other are contradictory. And then these two things in the corner from each other are also contradictory. And then we have subcontrary. So they can both be true, but it cannot both be false. And so if we say that, that some humans are male, then it can also be true that some humans are not male. But if we say that some humans are, if we say that it's false that some humans are male, then I guess we would say that it is false that some humans are not male. And so those two things can both be true, but they cannot both be false. And so that is sort of that table there that you'll often see in introductory logic courses. And so let's look at some of these in more concrete terms here. And so we have this syllogism here. So all humans are mortal. That's sort of the major premise. Then the minor premise, Socrates is human, therefore Socrates is mortal. And then I put in sort of the more abstract version here. So all x is y, s is x, therefore s is y. And so we can see that over here pictorially. So inside this orange box is all things that are mortal, and a portion of that are humans, and they are all within the mortal. They are all within the category of mortal things, and so therefore, if Socrates is within this circle of all human things, then Socrates is necessarily within this this realm here of all the mortal things. Or you can look at it this way, and this is actually the way you would probably see it in a logic textbook. And so we see that we have the mortals and the humans overlapping, but I've sort of grayed out the humans that are not overlapping with mortals, and that's telling us that only humans that are also mortals are humans that exist, and we see that Socrates falls into there. And so that is kind of how to look at that pictorially. So that is looking at the major premise as being the every S is P, or the all S are P. And then if we look at sort of the one in the upper right, so no S is P, then we have this situation down here. So no humans are birds is the major premise. Socrates is human is the minor premise. Then we have as our conclusion, therefore Socrates is not a bird. And so I kind of moved this blue circle out here. But what you'll probably see more often is this over here. So I grayed out here where they overlap because there are no humans that are also birds, and so those things do not overlap, and so we can see that that is similar to what we had over here. And so those are fairly straightforward. Where things usually get trickier is when we get into the some. So if we have some humans are male as our major premise, and Socrates is human, does it follow then that Socrates is male? Well, not necessarily, because we say that some humans are male, and so we are saying that this right here is possible, that there are some in there, and we are saying that there are some in here. But all we know is that Socrates falls within the human circle here, so Socrates could fall right there, or Socrates could fall right there. So this is not a valid syllogism. And in the next video, I'm actually going to go into more detail about how these syllogisms sort of can fail, and sort of the ways that people actually screw it up and can make invalid statements. And so that actually brings me to how I'm going to conclude this video, which is the difference in logic between validity, so validity, and what's called soundness. And so validity is that the conclusion follows from the premises. And so that is not saying anything about whether the syllogism is true, because we can say something completely false. We could say I don't know, maybe that, I mean, we could even say that all humans, I'll just use H, are birds, and so this we know is not true. But if we say all H are B, all humans are birds, and Socrates is human, then we could say that Socrates is a bird. So this is valid. This is a valid syllogism here, because if the premises are true, so we have premise 1 up here, and premise 2 right here, and then the conclusion. If these two premises are true, then the conclusion is true. So the conclusion follows from the premises. But then what the other thing that we are interested in is soundness, which is the premises are true. So this syllogism here would be valid, but not sound. And so those are sort of two things we want to think about when we're talking about logic. Is the logic valid, and are the premises sound? And so I remember when I took Intro to Logic, my professor said that logicians are only concerned with validity. We can leave soundness to the lawyers. But I mean, both of these things are important in logic. But I think, soundness is one of those things that, people can debate online, whether this or that is true. But sort of where like logical fallacies come in is in this realm of validity, where people try to make a conclusion using premises from which that conclusion would not follow. And so that's actually what I'm going to be looking at in the next video. But in this video, like I said, I just wanted to give sort of a quick overview of propositional logic. So we looked at these truth tables with the and in the inclusive or. We looked at the negation or not symbol. We looked at these hypotheticals, which are the if-then statements, which I'll also be talking more about in the future, and including things like the if and only if and stuff like that. So this stuff down here, so below this line, was all what is called categorical syllogisms. So uh, there's there are hypothetical syllogisms and there are categorical syllogisms. So hypothetical syllogisms are these ones where they're only valid when we use the modus ponens or modus tollens. So this over here was an invalid syllogism or hypothetical here, and this is also invalid. You cannot conclude that if P then Q, that does not entail that if Q then P. So you can't affirm the consequent in order to affirm the antecedent. And so these first two syllogisms up here were both valid, and it just also happened to be that they are both sound. A lot of times in logic courses, they like to give you syllogisms that are valid but not sound because it can kind of trip you up a little bit. But like I said, in logic, a lot of times what they're mostly concerned about is validity and not so much soundness. So they'll give you either premises that are clearly not sound, but you're only looking for validity, or sometimes they'll even just give sort of a bunch of nonsense. So all whizzle wazzles are fermimons. Lucas is a whizzle wazzle, therefore Lucas is a fermimon, or whatever. Just looking at validity rather than at the soundness. This third one down here was not valid. So this was not valid because, like I said, the conclusion here that Socrates is male does not follow because just given the premises, Socrates could have fallen into humans over here outside of the realm of males. And so, yeah, that is sort of this first quick introduction to logic. Like I said, in the next one, I'll be talking a little bit more about fallacies and things like that. I'll probably also talk a little bit more about these sort of hypotheticals, and in particular talking about the sort of if and only if type statements. And I've been debating with myself about whether to do a quantificational or predicate logic video because that's kind of where logic is in philosophy right now, and so it's important there, but it tends not to be that important when we're just thinking about just rationality, just humans being rational in sort of everyday situations. But quantificational or predicate logic is something that's really interesting, and it's a lot more, I guess, on the sort of cutting edge of where the philosophy of logic is. So let me know in the comments if you would be interested in a video on quantificational logic. But anyway, I hope you found this video helpful, and I will see you in another video.